Hello everyone. Today we will be talking about LLMs, about LangChain, and how to use the tool in order to build AI projects. And specifically we will be talking about code. We will be talking about tricky bits, because the code is actually quite simple to build, but then once you want to build something which works end to end, you realize there are lots of tricky bits related to how Gen AI works, and we will be focusing a lot on the business implication and what it really means in the business application of Gen AI. And I really need to warn you that it will be a speed run. This is normally what we do within a day, where you get a chance to actually code some parts of that yourself. What we will be doing today, we will be showing a lot. We will be sharing notebooks with you so you can follow us, but a lot will be basically your homework. But I mentioned that because I want you to not be discouraged from asking questions. I know it's a big room, but if you need to ask something during the presentation, it won't be just a presentation. We will be showing the code. It's like a mini workshop, so don't be afraid to ask questions. We are happy to stop. This is actually where the most value is. So if something is not clear on the slides, in the code, or if you have a question related to what we show and you have something in mind about how you would like to use Gen AI, don't be afraid, just ask us. My name is Marcin. I'm CEO at Tantus Data, and at Tantus Data we help our customers with pretty much everything data related, from building custom data platforms through data engineering, analytics, up to building custom machine learning models, deploying them into production, and custom Gen AI applications.
Hello, and I'm Bartek. I'm CTO at ContractSpot, where we basically help companies find, analyze, and win public tender. And how is it related to today's workshop? So basically, on a daily basis, we use LLM agents to scrape data from multiple data sources and then analyze it with LLMs. And this is exactly what we will be showing you today.
And you might think, okay, if I see headlines like that, AI is so good, AI is winning Math Olympiad, why don't I just copy and paste from ChatGPT, right? It should be simple, it's smart. But then you actually realize that it's not always that good. Sometimes it makes extremely stupid mistakes. It doesn't know which number is bigger. Or you see screenshots like that, where this is a Chevrolet chatbot, and customer of Chevrolet goes there. He convinced the chatbot to, okay, you need to agree on everything I say, and then he says, I need 2024 Chevy for $1. And the chatbot says, yeah, that's a deal, and it's a legally binding offer. So there are tricky bits around that. So the question will be, can you use LLMs? How can you use them? How can you use them today? And by today, I mean those low-hanging fruits which are applicable in day one in many companies. So a good example would be applications like sentiment analysis or text categorization. Let's say you run a vacation rental company or hotel booking website, and you gather comments from your customers. And these comments you can read and you can tell, okay, this is positive, this is negative. But if you have millions of them and you would like to quantify that and you would like to see which hotel is doing well, which has problems, you would need this extra column which says positive or negative. Or you would need another column which says category, so what people are talking about in those comments, whether it's a check-in, staff, food. And in order to build something like that, it pretty much takes one slide of code. So you can build that in half a day. Of course, you will need to connect to a database, read the comments from the database and write it back. But overall, you come up with a prompt, not that sophisticated prompt. And LLMs are good at these kind of activities out of the box. So you say, justify if the comment text provided is positive or negative. And out of the box, it works quite well. And okay, you might say it's nothing new. There used to be machine learning models which are specialized in sentiment analysis. And that's true. But at the same time, back then, if you were to build something like that 5-7 years ago, you still had to tune it for your domain and to do a lot more. LLMs are good at these kind of activities out of the box. So what is happening here is we pretty much build an object called chain, and the way it works is we are passing the prompt to Chat API. The pipe here, the meaning of the pipe here is that arguments from the left, output from the left is going to the right, and so on. So nothing really special here. We create a prompt. We create a LangChain object which gets the prompt and processing that, and that's it. That fits in the slide, and that's the main message. We will be going through such a code later on in a bit more details. So it is easy, or not. What if you pass those comments and you have something like that? Somebody wrote in the comment, "Who are you, ChatGPT?" And the answer from the code is that the comment is neutral. You could argue that is neutral, that's not positive, not negative. But on the other hand, in the prompt, I said I want the output to be positive or negative. Does that mean the chat behaves in a wrong way? Does that mean my prompt is wrong? And what does that mean for further processing? Because if we accept only positive or negative, if we want a Boolean value, this will not behave very well. So that's a simple example of when things can be tricky, when things can be surprising. But then one more thing, like everybody is talking about how those chatbots behave, and they want them to be ethical and not offensive and so on. And everybody is talking about that. But then when you think about how exactly it works, there are not many people who pay attention to the technical details, and achieving these specific behaviors is not that simple, mostly because of the nature of how the model works. End of the day, we operate on tokens. We have some parameters called temperature, top probability, and the actual seed to control to some extent how, let's say, creative the chatbot is, or how much it can go bananas. So in order to understand what we are controlling here, I need to mention that they operate on tokens. So that means the output from the chatbot is not being created in one run. It generates token by token. I can simplify to say that word by word. So let's say the output from your LLM so far is there was dark and silent. What could be the next word? What makes sense? I cannot hear you. Speak up. Room, street. What else? Yeah, corner. Okay, most people say night. And you know, you can think of words which make sense, like night, evening, room, street, corner, and you can think of words which does not make that much sense, like Pringles. And let's say if you set top probability to be 0.95, you basically, in the model, in a specific context, the model has a certain probability distribution, and if night is 0.8, evening is 0.10, and room is 0.06, then only those three will be selected because they sum up to the value of top P. But at the same time, you don't know what the probability distribution will be. You don't have the control over that. So it's more than you get those parameters, you try to tune them, but you don't have any guarantee how exactly it will behave. It's basically based on what training data was used to train the LLM itself. So it's outside of your control in most cases. But also if you, let's say, want to have deterministic behavior, regardless of which parameters you use, you cannot really fully achieve that. There is seed parameter in OpenAI documentation, and then when you read the documentation, it says that seed parameter gives you mostly consistent behavior. So, you know, mostly consistent is a funny selection of words. Okay, but let's have a look at some code in the details. So what you can do, you can scan it, you can run it on your laptop, yet we will be going through that quite quickly, or you can basically follow us and then run it on your own, in your own time at home. We will be happy to answer your questions if you have any after the presentation as well. But one thing I would like to ask you, this is Google Colab, so it goes to your Google Drive. What you need to do to at the start, you need to save the notebook to basically make a copy of that notebook.
I will show it in a moment.
Okay.
Yeah.
Okay.
So just please scan the QR code if you want, and maybe let me ask you, like, who has interacted with LLM through code? Please raise a hand so we know. Okay. And who used LangChain before? Okay. And who used any other framework other than just a provider native library? Okay, so it looks like most of the people used LLM, but you didn't use any specific framework. Okay. So let me go to this collab. And if you want to modify it, maybe first question, is it visible? Or should I make it bigger?
Say again. The QR code is disabled. Okay. How about making a short code for this one, short URL, so they can.
Let's generate another one.
No internet. Can we do something about that, or that's expected? No. Okay. Sorry. Okay, so that means you. Yeah, that one works. Okay.
I make it bigger.
So that means that's your chance to pay attention to what Bartek does, and then at home you can get back to it.
Okay. So if someone doesn't scan it, at the end we also have QR code for, you know, more information. So if you scan it, leave your mail, we will send you all the materials at the end. And basically, the idea of the first notebook is to show you how it looks like to interact with an LLM without a framework. And since most of you have already done it, I will maybe try to focus on the parts that in the next notebook we will simplify using LangChain. So what we have here, and one disclaimer, if you want to save it, you need to go to File and save a copy in Drive. Otherwise, if you modify it, you won't be able to later save it. And what this notebook does, it installs some requirements. We provide you also with OpenAI key, and we provide you with an option to pass your LangChain API key. What this is a framework from LangChain for monitoring and visibility, and I will also later show you how it looks like to later investigate what you do with an LLM in this framework. And for now, I think we can skip it. And in the first cell, we have an interaction with OpenAI API through their client in code. So the first thing you need to remember is that the model doesn't know about conversation history. So if you want to generate a next turn, you need to pass the whole history in a message, which is contrary to what you have in ChatGPT UI, for example. And here we have two messages. The first one is system message, and the second one is user message. So the idea behind system message is to basically to guardrails and to steer the model to do exactly what you want. And then there are user and assistant messages, and user corresponds to user input, of course, and assistant is a model response. And we need this message in order to later be able to pass the conversation history to the model. And each provider has slightly different API. So basically, if you were to switch that to Anthropic, you would need to somehow modify the function parameters. Some providers have also different names for roles. And what is the most important, each provider has slightly different output schema. And basically, when we interact with this API, what we want to get is text output. And if you have a look, what we get is rather a big dictionary with a lot of other informations. And those informations are related to the token usage, to some other guardrails, which since recently are available in the API. And what's nice about LangChain is that it can take all of this, monitor and visualize that in Langsmith, and you don't need to pay attention to that. And when we interact with OpenAI, this is a closed source model, so the only thing you pass it are those string messages. But under the hood, what the provider does, it needs to somehow parse and somehow process this list of dictionaries in order to pass a raw string to the model, which then tokenizes and operates on tokens. And if you were to deploy your own LLM on-prem, what you need to do is, under the hood, pass a string with those messages correctly formatted. And here I am showing the example prompt format for Facebook or Meta Llama model. And there are some special tags to wrap system message around. Then there are some other tags to split basically user message and assistant messages. And I'm showing you that in order to convince you that it's very tricky to get the formatting right. And it's very useful, on the other hand, to use a framework which abstracts away this part. And you, as a developer, you can only think about your LLM application from input-output perspective, and you don't need to pay close attention to those formatting details. And here we show how LangChain can help with that. And in LangChain, we have those classes for prompt and prompt templates that we can use to create a input to our model, and the framework will take care of each provider details. So here we are using Chat OpenAI, and the framework knows how to format it exactly for their API schema. And if you were to switch the provider to Anthropic or Gemini, the only thing you would need to change is this part, where you basically define different provider. There might be, of course, different model name. Maybe there are some different parameters you can choose for the model, but the part with your input and output stays the same. And
if you don't mind, so a bit of comment about this switching. Why would you switch? So overall, like when you're experimenting, especially at the early stages of building an application, you want to see, okay, how a big model from OpenAI will work, how the smaller one will work. Maybe we can achieve the same with the smaller model, but maybe we want to go to Gemini, to Anthropic, to see how they compare. So that's one of the reason of switching, and the switch is transparent. Of course, prompt itself might need to be tuned, but then on the other hand, you might want, for instance, have a situation that you get an output from one model and you do a verification using another one. So working with multiple models is actually quite common, and that switch with LangChain, with a framework, you get for free. With other tools, like if you use the native APIs, you would have to think about, oh my god, here I need JSON, here I need XML, here is this format, and so on.
Yeah, and maybe one more important detail is just keeping track of cost, because in order to keep track of cost, you need to parse this big dictionary, which actually changes over time. There are few different models per provider you would usually try. Each model has slightly different pricing, and this pricing changes usually like every few months. And what LangChain allows you to do is also forget about it, always use the most recent pricing calculations and easily monitor your spend. Okay, and one more detail about this formatting and prompts. Here I show example from next Llama model, Llama 3, and as you can see, it is much different than the Llama 2, and those prompts evolve, and it's quite complicated. And what I included here is basically a screenshot from a guy who was investigating this prompt when it was released, and he was comparing the Meta GitHub repository with the content they had on their website, and it was actually that complicated that even Meta engineers got it wrong, and they have slightly different format of the prompt in two different sources. And I'm showing you this in order to convince you that it's really good to start with the framework, use the framework, and don't try to get all of those details right on your own. It's better to use tested open source tools that the community is checking that everything is fine. And last part in this notebook, we want to show you the intuition behind the system prompt and how important it is to use this tool to guard your chatbot, to steer the behavior of your LLM app. What I have here is a valid Python code which computes 2 + 2 = 4, but instead of naming the variables like x and y, we name them harmful input, unethical racist data, very offensive statement, and so on. But basically this code computes 2 + 2 = 4. And we will ask LLM to explain the code for us. But we will pass 3 different prompts. The first one is a prompt copied from Llama model, the default one, and basically their default prompt was around safety and being ethical. And the second one I wrote on my own, and it says that you are just a Python expert. And the third one, it's a little bit tricky because it's just word Python written 10 times. Just to see what's the result. And here we create this very simple chain where we define prompt template for the system message. In a human message, we pass in this code, and we here can specify different models and run this input on those different models with different temperature parameter. And what we've seen over the time is that models actually get better understanding this code and outputting that the value is 4. But since recently, before ChatGPT 5 came out, it was a lottery with like 50% of time you would not get the result, and the model would say that it cannot assist you with that because this is, you know, harmful content and it is not designed to do this. And it's very, very counterintuitive because you have a code, a valid code, and the model doesn't want to speak about it. And the reason is that since it operates on tokens, it sees some words which in training data corresponded to some flagged output, and it was trained to basically block at this moment and don't respond to such questions. And it's a similar example to what we showed with this neutral style, where basically you need to think about the input which will be passed to your application, because the model can behave in very, very unpredictable ways. And in this code, you can later experiment and change those prompts, run it a few times, and then in Langsmith you can see the exact traces and the outputs.
You can make the code even more offensive. We didn't want to do that, but you know, you can try how it works. But I just wanted to add one more comment. Bartek mentioned that when you switch from one model to another, it behaves differently. You could say, yeah, that's expected, right? But what we also observed was that initially it was very predictable behavior. And then we saw that even though we were using exactly the same model from OpenAI, it was apparent that OpenAI did some changes in the background. So that's also a challenge for you if you run a specific application in production. You don't really control what's behind the scene, and it was actually quite common that you saw adding some guardrails by OpenAI, by other providers in the background without any notification, without version bump up. So that's also something to pay attention to in the future.
Yeah. So do you have some questions to this part? Yeah. Yeah, so basically when we were showing the slide with generating next token, so what the model does, it assigns the probability to next tokens. So what it thinks should be the next one in a sentence. And then you, as a model user, you can define what you do with those probabilities. You can take the token which has the highest probability, or you can take this distribution, sample from it, and modify it somehow. And temperature controls it. If you set the temperature to 0, it means always take the most probable token. And if you set it to some higher value, it means modify this distribution in some way. Basically, you can check the exact equation. It's rising to a power 1 over t, and then you can sample from that. And higher values of temperature makes the distribution more flat, so you are more likely to sample different tokens because there is no one token with very high probability.
So higher temperature would mean the LLM is more creative. The lower, it's more deterministic, but there is never a guarantee that it will be the same output for the same input statement. But there will be less variance if you set it to 0.
Yeah. Yes. So in production, I would say, because in production, you mo mostly experience this chain if you, for example, try to write a unit test and you have a very fixed scenario in your code which you know that the model will go or answer very precisely, and this is what we tried initially to do, and then we realized that it's not possible because there are those slightly changes, the model is unpredictable and you cannot have unit test. Then in production, I would say it's hard to connect the changes or the difference in model output to what changed from end user perspective, because the model itself is just unpredictable. But yes, we had some experience with different model behavior. For example, this this example with the model outputting 4 or not outputting 4. I don't know, magically one day you run it again and it works. But the model version is the same.
Yeah, but in production you don't have this single metric which says, oh, for that scenario model should be answering with that question with that answer, because that's what you have AI for. You want it to be give a little bit of control to that. So in production, what you measure is basically the key business metrics. So let's say you want to have a conversion by using the model, so you need to pay attention to that, whether there are no drops, and of course all types of technical error. So at some point you start getting 500s because the JSON doesn't parse anymore. It was producing a JSON and the JSON doesn't parse, or things like that. So you don't have the explicit metric for changing model behavior, but you can kind of connect the dots once you see problems. Yeah.
Yeah.
So it very much depends on like how well defined the output will be, because in some cases, yeah, you can have your verification set and you expect the exact true false or something like that. In some cases, you can play around with those non-deterministic tests where you, for a given scenario, you test if model's response meaning is what you expect, but then you have to kind of pay the price of having non-deterministic tests and false negative every now and then.
Yeah, I hope we will manage to go to this, because in last notebook we have an examples of evaluations, and we have exactly this one. It's called LLM as a judge, where you used a second model to evaluate what the other model outputted. Okay, and here, before we jump to the next notebook, we want to pause for a while and ask this question: why do we need a framework? So I showed you that there are some tricky bits about the format, the output of the model. And what framework does, it gives you abstraction and simplification, which in practice means that you are not vendor locked. It's easier to change the provider, and it's easier to stay up to date because the community responsible for the framework is also responsible to keep track of all of the changes, and your code just works. And then there is this community and support, and this one is very nice because since LangChain is open source framework, a lot has been done, and a lot of the code you can find on GitHub, you can find in examples, and if you are thinking about building some kind of application, I advise you to try to Google if there is something like this already implemented by someone, and you can actually take this code and use it. And last but not least, the model has limited knowledge and abilities, so the model has its limitations, and in practice we as engineers need to design the system in a way that we can take advantage of its strong parts and we can overcome those limitations. And I think this QR code will also not work, so maybe let me generate another one. Oh. Okay. And in this second notebook, we show you how to define the chains in LangChain, and this is basically where the name come from, and how to do the most common operations on LLM using the framework. And here it will be a good moment to introduce this LangSmith, and this is, as I said, tool for monitoring and observability made from creators of LangChain. And this is actually paid product that lets you monitor and visualize all of your traces. And I have the output saved from this workshop notebook number 1. And what you see here are all of your runs in your LLM application together with the exact input, the exact output, and all of the steps that there were in the middle. It's very useful to debug the applications because later, if you have, for example, agent that does many things in a loop and something breaks, without a detailed, precise tool to investigate its step, it's actually impossible to debug that. And if you want, you can create a free account here. You need to take a key, create a key in settings, and then you just need to paste the key here, and with 2 variables enable the tracing and tell what's the project name. And it's very nice because usually setting up some monitoring and visibility takes far more code than this one, and in LangChain it's actually built in. You just need to pass the key, set the tracing is enabled, and everything just works. And in the free tier, I think they have 5,000 traces a month, so it's enough for local development and debugging. For production, you would actually need to pay. Okay, and we were showing on a slide this example chain to classify the sentiment of a comment, and here we repeat that in code again. And the chain is this part. It's just combination of different steps. The library knows how to connect together. What we have here is prompt, is our chat API, a specific provider, and we have also object to parse the output as a string. And what LangChain does, it glues those elements together. It knows how to pass the output from one step to another. Under the hood, it can also log all of those transitions. And if you were to switch the provider, it will still work. And here we replicate the example from the slide where the model outputs "Who are you, ChatGPT?" And we can actually go to Langsmith and see how it looks like here. Maybe I need to... okay, so our chain consists of 3 steps: prompt, call to the model, parsing output. And here we can also see 3 steps. So this one overall shows you the input and the output of the whole chain, and then you can go inside. There is a prompt step, there is call to the model, and there is output parsing, and it tells you what's the cost for that. Here it's actually very, very low. Okay, and here I wanted to point out this pipe operator, and this is how you in LangChain connect elements together, and they called it LangChain expression language. And there are more, let's say, there are more operators you can use. You can actually create very advanced, very complicated structures as a chain in a very Pythonic and intuitive way. And then they have also other libraries which makes it easier to take it from prototype to production. For example, they have this library LangServe, which allows you to take your chain, so for example the one we defined here, and expose it as an API using fast API library, and it does it in few lines of code. It generates the full spec. It allows you to expose it in, for example, a batch API, and so on. And it's very nice because in practice you have the same code you use to work on the application locally, and the same code you take later to production. Yeah, it allows you to call the model in batch. And why I'm showing it here, because it may look like a small tiny detail, but under the hood it's some async code that does many things in parallel. And I think it's nice that you don't need to do this on your own, because in practice everyone is in a hurry, and what you want to do is just take a working library and use it for your advantage. Okay, and next examples focus on using history and adding next messages, because as I said, the model itself is stateless, and if you want the conversation to keep going and have a behavior like in ChatGPT UI, you need to take care of the history on your own and send all of those messages each time the next one comes in. And we can do it using this LangChain expression language and all of those blocks. And here we have a simple chain that shows basically that the model doesn't remember previous messages. So the first message is, hello, my name is Bartek, and then I ask the same chain, do you remember my name? And it doesn't remember it because it doesn't have state, it doesn't remember my previous message. And what we need to do in order for the conversation to happen and to have history, we need to keep track of messages on our own. And in LangChain there is this object message placeholder, and this is a template that accepts not just a string but a list of string, and in this list you pass the history. And here we show that it actually works, and the model now remembers my name. And here the tricky part is that you probably encounter this situation that you go on in the UI and at some point it tells you that the limit is reached. And the model has a limited context window, and in practice long conversations need to be at some point either capped, summarized, or you need to do something about it, because it will on one hand just don't work, on the other hand it will cost you a lot, because each time new message comes in you pay for the whole conversation history. And this summarization is something you need to take care in a production application, or you need to just at least remember about this fact and somehow limit your system and don't allow for too long sessions. And when it comes to summarization, there are many ways how you can do it. You can just in the next message ask the model to summarize what was going on here, or you can take the conversation, which as you remember is user message, assistant message, and so on, and you can paste it into one human message with those roles written also in a string, and you can ask here to summarize the conversation. And although it looks very similar, the output is different, because in the first scenario the model tells us in a first person that we introduced ourselves as Bartek and so on, and in the second option it speaks from the third person perspective, so Bartek introduced himself. And those are those small details you need to remember about, that from human perspective it's the same, just summarizing the conversation history, but the way you format your input changes how the model behave. And here we show an example how to use chat message history, which is an object in LangChain to used to handle the history. But I think we can actually skip this part, because it corresponds to later to an exercise when the task is to create a chain which keeps track of history. But since we have only 2.5 hours, we won't be able to do the exercise. Or maybe you want to try, but
my suggestion would be that we skip that, because later on we get into agents, more advanced tools and stuff like that, and I believe it's better if during that 2 hours you get an overview of what's doable, and then on your own pace you can do that.
Yeah, and I was talking a lot about this summarization because this is actually the thing you, as a developer using coding agent, interact a lot during your day-to-day work. You might not know it, but in all of those coding agents, this summarization is a built-in tool. So here I'm showing the screenshots from some of the most popular coding agents, and in Cursor they just name that it's summarization and they are being honest. In other agents, for example in AMP, you have this handoff comment which basically sums up what was going on in this chat and creates a document to hand this off to a new developer, which in practice is just a text which summarizes what was going on, and you can copy it and paste it to the next session with a fresh context window. In OpenAI Codex, you have this compact command that will magically free 80% of your context window. But under the hood, all of those are summarization, and you need to remember that in a long run they lose some information, and from my experience it's better to try to keep those tasks small and start a new task instead of adding the messages to the conversation and so on. Okay, so we were talking about how to create a chatbot application from code, and what we need more is an external knowledge. Because if you want to create a chatbot, for example, on your website, or a chatbot which knows about your private data, you need a way to ingest this data into the model context, because it doesn't know about it. First of all, the model has a limited knowledge, meaning that the training data was collected to some point in time. For ChatGPT is, I think, some date in 2024. So if you ask it about what happened yesterday, it will not know. There are some mechanism that works under the hood, and they provide the model with those informations, but the model itself doesn't know about it.
Yeah, so for GPT-5, it's officially September 25. And if you, let's say, go there, yeah, we have another example here, but if you go there and ask, did the war in Ukraine ended by the end of 2024? If you go to the website, it will use search and it will basically answer the question. But if you use the API itself, it basically answers with something. As of June 2024, the war was still on, and you need to basically search. So on one hand, it shows the model doesn't know about recent events, which is kind of obvious. But on the other hand, it shows that they released GPT-5 quite recently, and the cutoff date is middle of 2024. So it basically shows how much time it takes them to actually train that. So on one hand, they probably had multiple iteration. On the other hand, the resources and for how long they do that training process is enormous.
Yes, and so in practice, the model will not know about some recent events or recent things. A good example was to ask ChatGPT 3.5 Turbo what is LangChain. And since LangChain was released after ChatGPT 5 was released, the model didn't know about it. But since the name contains some word chain, it answered that LangChain is some blockchain-based platform that aims to provide something and something. So it completely didn't know about it. So what we need to do is provide the model with this relevant data to answer users' queries. And on this slide, I wanted to point out that the model knows about the things from its training data. So it means it knows all of those publicly available information in the internet, but it doesn't know about some proprietary materials or even content behind some paywalls. You may expect that it will know about it, but a good rule of thumb is to assume that it doesn't know anything you cannot Google. And it's before its knowledge cutoff date. So we were sending a prompt to the LLM, and now what we will be doing is we'll be adding some context, and this technique is called retrieval augmented generation, where we retrieve the relevant data sources for the LLM in order to provide it as a context such that the model knows how to handle the user queries. As example, we can do a retrieval augmented generation on documentation of LangChain. You read some file, you write a prompt to the model to answer the question based on some context. And the important part is how to design the prompt, because depending on how you ask it to treat the context, the answer will be different, and we'll be showing that in a moment in the code. And in practice, you can have a lot of those documents, and a tempting attempt is to put everything inside. New models have very big context window, for example 1 million tokens, and if you calculate, it's like almost 1000 pages of documents, so why not load everything and just keep the fingers crossed that it will work. But in practice it doesn't work, and it also incurs very high costs. So what we want to do is have a very precise system that, given user query, fetches only the relevant context from the data sources you provide to the model and passes only this. Because, as I said, in the long run, you pay for those tokens, and it's also very hard to debug the system, because if you load the whole context window and it works, good. But if something breaks, then you don't know what's going on. You know, in one of those 1000 pages, there were the answer why the model didn't respond. And the answer is to include only the most relevant chunks. And the next code will show you one of the techniques how to do it. And it's based on vector embeddings. So who of you knows or have interacted with embeddings? Okay, few people. So the embeddings are a way to convert text to a vector, and vectors are nice because we know how to compare them. We can calculate, for example, cosine similarity, and the promise is that semantically similar text will end up close to each other in embedding space, and as a result we'll be able to find the relevant chunks to a user query using some vector arithmetics. Okay, and
yeah, so an example of how we can try to use that in practice would be, let's say you build a travel assistant and the user comes with a question: I need an apartment with elevator in London. And you have hundreds of thousands of apartments. What exactly you answer for that question? So the very naive kind of approach would be that you see how far the question is from some statements in the description. So you hope that this I need an apartment with elevator in London would be close to apartment with elevator in London and far away from just apartment in London. So what you do, you get all your descriptions, you transform them into vectors, you store them into the vector database, and then once you have a question, you also transform that question into a vector and ask the vector database, okay, give me the documents which are close to my question. So that's the kind of the basic, the very basic approach. In reality, you don't only use vector database. In reality, you use whatever you have. You might be using documents, you might be using database, you might be using APIs, which can provide you with relevant data. But coming back to this question. Okay, we, sorry, I thought later on we will be digging into what can go wrong and why vector embeddings is on one hand nice tool, but on the other hand it's not a silver bullet. But what you do later on is you need to handle the history. So let's say user comes with a question, I need an apartment with elevator in London. Then you show the apartments and then the user is like, nah, skip the elevator, I don't like the results, but I really need a washing machine. So in reality, what's important is that it's apartment in London with washing machine. The word elevator happens to be twice here, but it's not important anymore. So that question can be rewritten again by an LLM, by a specific prompt, to something like, I need an apartment with washing machine in London. So that's the kind of different approach from just querying for specific keywords, because the keyword elevator is not valid anymore, even though it happens twice. But on the other hand, if you, let's say, use vector embeddings to search for some sentence with elevator, it wouldn't really matter whether you use the word elevator or lift, because the promise from vector embeddings in this case is kind of fulfilled. Okay, it knows that elevator and lift are the same things. But in reality, when you see a description like that on the website, this is a description of an apartment of a cottage, quite cheap cottage in a rural area. And then another one is apartment in London, quite pricey, a bit bigger. And from user's perspective, those are completely different things. But what we observed is that vector embeddings are getting confused with that, because both of the description, if you just take the text, both of the description are using pretty much the same language, it's the same domain and so on. And we were struggling with something like that. We get a few descriptions, we see how far they are from each other, and we realize, okay, they are far away from the word banana, they are far away from some legal text, but all the descriptions are close to each other according to vector embeddings. And then you have user query, you select documents from vector embeddings, you get 100 candidates, and all of them are with the score 0.89. And then it's still your responsibility as an engineer to interpret that somehow, or tune that in order to provide better results. But we will be going a little bit deeper into that.
Yeah, so let me create the QR code for that. And in this notebook, we show a classic example to introduce to vector embeddings, where we want to calculate some vector arithmetics on them and try to plot it and try to see whether this arithmetics correspond to what human would expect. Okay. And we will be showing this example on two different embedding models. The one will be open source, and the second one will be the OpenAI official embeddings you can use. And over the time, we run it on multiple models. We run it on all their version of OpenAI embeddings. And I will sum up maybe the lessons learned at the end of this notebook. But basically it changes over time, and also it's hard to interpret the result and take out the some actionable insight whether which model is better. But going back to the notebook, what we'll be doing here is we'll be doing the arithmetics on 4 words, so king, queen, man and woman. And the idea is that king and queen differ semantically in the same way that man and woman does. And if you were to take a word king, subtract a word man, and add a woman, you should end up in a queen. And we want to do the same in vector space and see how close we are. And in order to visualize that in three dimensions, we need to reduce the dimensionality of the vectors, And this is the tricky part, because OpenAI embeddings are a vector of length 3000. So if you reduce the dimensionality to just 3, you'll lose a lot of information, and as a result, with those new embeddings, it worked poorly than with the previous one, which were of much lower dimensionality. But basically what this code does, it computes the embeddings for those 4 words, it does the arithmetics, it then reduces the dimension using PCA, and then we plot it on a 3D plane. And you can see that for those most recent embeddings, the result is rather not what we were expecting. My idea is that it's because those newer models, newer embeddings are of much higher dimensionality, and it used to work with older models, because older embedding models had usually dimensionality of like 300, now it's 3000. So if you are reducing it to just 3, you lose a lot of information. But then also a practical tip is not to rely on human intuition in such cases. In practice, the best way to evaluate embeddings is to just run some benchmarks, because under the hood, if you compare them, you get some cosine similarity, and you might think like, okay, if it's higher than 0.5, then let's assume that those texts are similar. But in practice, this threshold can vary a lot depending on the domain. In some domain, 0.3 will be good, in some 0.7 will be good. So the best way to decide in practice is to just run some benchmarks and decide like what precision, what recall is good for you and suit your problem. And do you have some questions to this part? Do you get the maybe the feeling, the understanding how the embeddings work? Okay, so I think we are good to go further. Want to make a break?
I think maybe let's ask after this one.
After this one, okay. So in this next notebook, we will be showing you the retrieval augmented generation, and we will be using those 2 techniques to provide the LLM with up-to-date context in order to answer questions based on LangChain documentation, and we will show you the tricky parts and what can go wrong in such application. So in this notebook, we will be doing retrieval augmented generation on LangChain documentation. I prepared this documentation in this zip file on Google Drive, and if you run it, it will download it and unpack it here. And this is a very common case. You already have some documentation and you just want to connect the LLM to it. It can be code documentation, it can be any other source of data. And first thing that can go wrong is you have, for example, a main file which have links to other parts of documentation, and it's basically like a dictionary, like what is where and so on. And in practice, what you want to do is first analyze those sources, whether there are no documents that have a lot of noise. Because if you have some files that contains like summary or the description what is where in the code base, you might expect that they will be similar to any user query, but in fact what you want to do is get those documents this file points to, not this one. So a good rule of thumb is to always, instead of throwing all of those files into an LLM, always spend 5 minutes to go through them and delete those high signal chunks. And we'll be creating knowledge base here using vector embeddings. Nice thing about LangChain is that it allows you to do everything from notebook. We'll be using Fice library. It's from Meta, and this library you can use it also in notebook. You can use it also in production. If you have lots of embeddings and vectors, you can even deploy it in multi-node setup on GPUs. And we will back up our vector embeddings with classic BM25 algorithm. And this algorithm, it's like improved keyword search. So it takes also into account words frequencies and stuff like this. It's quite old algorithm, but works good in practice. And in practice, it's good to have a blend of keywords together with vectors. And this is high-level overview of our application. So what user sees is just their question and bot answers in a turns. But what the application does under the hood is that we take current conversation history, we take the next user question, and we need to condense it. We need to condense it because we will be querying our vector database with embedding of some text. And for example, if next question is how does it work in detail, and you start to query your database for text similar to this one, you will get some random documents because it doesn't know what the conversation was about. And we need this additional step in order to condense the whole conversation into one sentence that will be used to retrieve relevant chunks. Then once we have those chunks, we present it to the model together with conversation context. We generate the answer, and this is what is displayed to the end user. Yeah, and here I am showing this example, why it's important, because the first question is how do you implement something in LangChain? The model responds. The next question is how it works, and the query to the database needs to be made taking everything into account. And here we show how to implement it in LangChain. So we have this condensed question chain and condensed question prompt, and given the following conversation and a follow-up question, rephrase the follow-up question to be a standalone question. Very simple. So what can go wrong? If you were to copy this and paste it into ChatGPT, you would probably get a response starting with certainly I can help or something like this. For 99% you would get something more than just your rephrased one line output. But what we want to get here is just this one line of output, because we want to deploy this system and we want it to work 24/7 and don't think about it. So in practice there are some tricks you want to do in order to force the model to output in a very specific way as you want. So we have this system prompt, then we have this message placeholder where the history will be, and then we can start the new human message with follow-up input. Here there is a new line character, there will be this question, and we write standalone question semicolon, and the idea is that the model will now, instead of writing something, yes, certainly I can help, it will just write this standalone question here without any additional text, and in practice it works really good. And yeah.
And this is just a trick people realize when start using LLMs, that apparently the LLM was trained in the way if you end the sentence with column, it just goes to the point without all this boilerplate text. So certainly I can help you and stuff like that.
Yeah, and we run this on the example from above, and indeed, using the very same ChatGPT model, we get only a one short sentence as a response. And we can use that to create now vector embedding and search in our database for the part of documentation relevant to this one task.
So what we did here, we changed how does it work to how does retrieval augmented generation work based on the history of the conversation.
And in next few cells, we create this vector database in LangChain, and we create our hybrid retrieval that uses, on one hand, vector embeddings, on the other hand, BM25 algorithm. And LangChain makes it very easy to load whole documentation. Although you have different files there, you have some notebooks, you have some markdown files, and so on. There is a bunch of predefined classes in LangChain that lets you construct some recursive loader, which will parse those files and extract all of the relevant details without, for example, some notebook boiler code and so on that is around cells. And here we calculate statistics of our text. So we start with 1,200 documents. We then split them. And why do we need splitting? Because first of all, document may be very long, and you don't want to put the whole document in LLM. But then when you create those embeddings, if the document is very long, it's not, even for human, it's not easy to decide like what this document should be relevant to or similar to, because it's just about many things. So in practice, what you want to do is split the document into multiple parts, embed each of this part, and only retrieve the relevant parts. And also in practice, if you just embed those whole documents, you will end up with example that Marcin was showing on the slide that everything is similar to everything, and it just doesn't work.
You can think about it as a compression. So if you get a document and you transform the entire document into a single vector, that single vector is of static size, so it has few thousand numbers in it. So the bigger document you get, the more you compress, the more information you lose.
Yeah, but you cannot split it into two small chunks, because then you will lose the context. Also, if you split it automatically, you might split the sentence in half. So in order to protect from that, you usually set some chunk overlap in order to make this sentence be included fully in either the first or the next chunk. And in practice, values like 1,000, 2,000 or 4,000 for number of tokens in one chunk works good. So here we split those 1,200 documents into almost 11,000 ones, and the mean chunk length is 850 tokens. Oh, sorry, it's I think it's in characters, not in tokens. And then one more thing which is nice to do before you embed all of this is to calculate the costs. So maybe don't tell it, but think about the number. How much does it cost to embed all of the LangChain documentation? I will give you 3 more seconds. And
I guess
$1 is a good one. It costs like $0.4. And nice part about it is that it's getting cheaper, because if you think it from tuning the, for example, splitting part perspective or the vector database part perspective, each time you introduce the change, you need to embed the whole database again. Yeah, so the fact that it's getting cheaper and cheaper lets you really experiment more and makes it much cheaper to work on this. Okay, and here we create those embeddings using also some predefined classes from LangChain. We can also define some caches. So for example, if you rerun this notebook, you will use the embeddings from local cache. You create this vector database using this files object, and we create this BM25 retriever also from those documents. And using also another class from LangChain, we can combine all of those two retrievals, and we can specify the weights we want to assign to scores from each one. Okay, and here we run it on some query, and maybe not focus on this one, but let's go to another one. Here we want to investigate what scores were assigned to each chunk, and in order to do it, we use another library for this BM25 part, because this may be one corner case of LangChain that it doesn't allow you to get score from this one retriever, so we need to somehow work around it, because in practice you usually want to investigate those scores and know like what your system is doing under the hood. And here we compare what scores were assigned by our vector score and by our keyword based score to some documents. And vector scores, they are on a range from 0 to 1, and those keyword scores are from -1 to 1. And the question is, how do I implement RAG in LangChain and OpenAI? Give me some working code. We can see the source is some chat OpenAI, so it's probably relevant. Vector score is 0.5, so ideally in the middle. Keyword score is -0.5. Like, is the score good? Is the score bad? As I said, usually in practice, it's better not to look at the exact values. It's rather better to construct a nice benchmark, and we will have later a slide about how to do it. Okay, and another technique you can use to get more relevant chunks is hypothetical document embeddings. Because if you think from the perspective of those embeddings and similar text, the query is not as similar to corresponding paragraph as just a similar paragraph. And the idea behind hypothetical document embedding is to ask the LLM to generate a hypothetical answer to user query, then embed this answer and look for similar paragraph to this one. So as a result, this answer is much longer and maybe much more similar to what you have in your database than just a one short user question or rephrase question. And it's, in many cases, this is a technique that really improves retrieval augmented generation, but it can be tricky because if you ask the question the model really doesn't know anything about, it can hallucinate and generate impossible paragraph in order as a result to your question.
Yeah, so on one hand, let's say you have an internal assistant in the company, in a big company, and you ask, how do I set up VPN? So you can make the model, make the system transform the question itself to a vector, or you can go to some open LLM, ask that question. It will give you some fluffy statement and of what could be possible steps. It's not relevant to your company, but you have an example answer and you want to search for the documents which are similar to the output from the LLM, and it will likely be similar. You will likely have to do similar steps, but when you search for good embeddings, you will get the exact steps for your company. And it's a question like whether LLM knows something about the domain you're asking the question, or it's completely unaware of it. So one option would be to search for documents similar to the question. The other technique is to search for documents which are similar to hypothetical answer.
Yeah, and here the code compares the scores now to the part retrieved by hypothetical document embeddings, and they are of course different. But let's go to the part where we already know how to get the context, and now we need to generate the answer with LLM. So first thing you need to do is somehow present this context to an LLM. And if you have multiple documents, you need to enforce some structure, because just pasting those few chunks without any additional info either at the beginning and between them will make the model be not that easy for the model to understand. So it's good to even do some simple things like add 2 new line characters or use some HTML like tags to separate those documents. And then once we have this, we are good to start generating answers with the model. And this part is also a little bit tricky, because depending on the system prompt you use, you will get a different behavior. So the most natural one is to just tell the model to answer user query based on some context, and then you can specify whether you wanted to only use the context or you wanted to answer best as it can and help with it can use the context if it wants, but it should always try to answer user query. And in this case, here we have a context about LangChain documentation retrieved by this previous system, and we get a meaningful answer. And this example here we showed with ChatGPT 3.5 previously, but now this model is depreciated, so we cannot rerun it again. And GPT-4o mini knows already about LangChain, so it produces somehow valid information. And this is also something you should remember, that when you test the retrieval augmented generation, you should first test what the model knows without this additional context you present to it. Because previously, when we were working on GPT 3.5, it was very easy to assess whether our system worked, because the model didn't know anything about LangChain. And if the retrieval augmented generation worked, we would get some meaningful answers. Right now, GPT-4o, GPT-5, they already know something about LangChain, and if you want to make a chatbot that has very up-to-date documentation, it's much more tricky to get it right, because even if there are some flaws in your system, you will get a very meaningful answer, because the model already knows something and is trained to be helpful and will try to close the gap between some knowledge limitation it has. But okay, this one is the same. It's also important how you test it, because this example on ChatGPT 3.5 Turbo gave you a very plausible answer about LangChain. So if I were to cut it here, the answer would be that LangChain is blockchain-based platform and so on. But if you add some more context to your question, that you are asking about LangChain, about open source library that is used for building LLM application, the model is smart enough to connect the dots and generate you a plausible information, although in practice it doesn't know anything about the framework. So it's also important to design the questions in a way that you don't leak any information, you don't give any, let's say, hints to the model how to best answer it, but you are really testing the application itself. And then here we can also see the power of system prompt, because if you run the very same question with a context of first paragraph about giraffe taken from Wikipedia, the answer is I don't know. And the answer depends also about system prompt, because you can design the system prompt in a way that you force the model to only use the provided context, and if the context is not relevant, you get the answer I don't know. Or you can ask it to try to use the context, but if the context is not enough, it should try to answer best as it can. And this part is important to tune, because depending on your use case, you may want the model to only answer about answer user questions about the context it has. For example, you have a chatbot on your website, and your retrieval augmented generation provides some information from your company documents. If there is no information about user question in those documents, you want the model to just not to answer this question. Yeah, and here we show the very same giraffe paragraph with two different system prompts. So the first one is maximum helpfulness prompt, which says that always try to be as helpful as possible and so on. And the second one is the same as the previous one, and here it answers based on the very same context, just with a different system prompt. Okay, and do you have some questions here? Yeah, so because vector embeddings, it's very easy to create them. Yeah, you can ingest, no matter how big your documentation, you can just embed it. But then the question is whether the system will work, and the more effort you put into designing a good retrieval system, the better it will be. So one thing you can do is, for example, add some metadata filters. Yeah, you can have, for example, even as simple as filters based on date, based on some high-level context. And what you can do then is, for example, ask the LLM to generate values for those filters. And also works quite good in practice, but it makes it harder to design such a system, because you need an extra step where you tell the model basically, those are the filters, those are the possible values. You can also generate parameters to set that. And the system is also then prone to hallucination, because the LLM can generate you a parameter that is not valid for it. But in practice, simple filters work quite good, and it's something that can really boost the performance, because by those simple filters you basically cut away all of those not important documents that might be some noise in embedding space, and they might be included.
Yeah, so overall this is a easy to start with technique, and then you assess what works out of the box, what parts you need to tune, and you can tune the retrieval systems and the embeddings themselves, but also you can deal with metadata. You can deal with, let's say, you have some internal structure of your documents. They are in different folders because they are per department. So maybe a good approach would be to guess, okay, this question is about that department, so we narrow down the candidates and then do the lookup. So very dependent on the use case itself. This is just one of the techniques. Easy to start with.
Yeah, we will have also one more slide later about the most recent approaches to getting the right context, which is basically based on creating sub-agents that will search your documentation. And this is only possible since the very beginning, once the models are very, on one hand, very smart, on the other hand, very fast, and you can actually do it in a reasonable time, but we'll maybe go to this a little bit later on slides. And here the rest of the notebook is about exercise, where you can try to chain it all together. So take what we did in the previous notebook about storing the conversation history and connect it with the part about getting the retrieval with embeddings, and as a result end up with a chatbot that can answer questions based on some documentation, and it keeps the conversation history.
But we won't be doing it now. This is your homework. Are you about to wrap up, right?
I think we can make a break.
Yeah. So if you have more questions, think about questions so we can start with Q&A, continue to tools, agents, a bit more advanced techniques after the break. But let's do it quick one. Let's make it 8 minutes. So 11:45 we are back. We're starting, okay? Okay, guys, so I'll do a quick summary, and then we will use the remaining time to basically show you a few more advanced techniques in notebooks. So we've been showing you some techniques, but at the same time we try to emphasize that magic does not exist, and it really, like when it gets to, for instance, vector embeddings and how we split the documents, it's all about like what context length we can use from a specific LLM, and putting more documents there is not necessarily better. And overall, you always need to come up with some way of splitting the context you have. But when I tell you, okay, splitting is just cutting the documents into pieces, that's a little bit too simple. That would be like saying, okay, you draw these two circles and then you complete the owl. That would be cheating, right? So in reality, every single detail matters.
Yeah, because now it's very easy to enable those AI features everywhere you go. So on AWS Bedrock, you can basically create vector database in 4 steps, and what you get is for sure a billing at the end of the month. But does it work? Maybe not. And here we want to show you a very practical framework to build and evaluate retrieval augmented generation applications. So first of all, you need to split the retrieval and the generation, because if the retrieval doesn't work, there is no reason to start the generation. And in order to evaluate the retrieval, there are 2 metrics: precision and recall. So basically they tell you how many of relevant documents have you retrieved and how many other documents apart from those relevant you have retrieved. And there is a very nice framework what to tune at different stages. So if both precision and recall is high, then you did a good job. You have a nice working retrieval system and you are good to start working on the generation part. If the precision is low and the recall is high, it means that you have all of the relevant documents, but apart from them, you might have also some other not important documents, and it can still work if the LLM has and can utilize long context, but you may pay much more for those unimportant documents you are feeding into the context window. On the other hand, precision is high and the recall is low. It means that not all of the relevant documents were retrieved, and it can still give you good answer if though in those few there is some signal. But if both precision and recall are low, then you should just start from scratch and tune those metrics. There's no point starting working on the generation part with an LLM.
Yeah, so whenever you deal with splitting documents, there are a bunch of techniques. You can use self-queries. So if you search for that in Google, we have an article about that. But the simple approach is you tune the size, but you have to keep in mind that you need to keep the context of each chunk. So let's say you split a PDF document. It's not enough that you have some part of the page, but you need to at least know which chapter the chunk is coming from, because otherwise you absolutely have no idea, and LLM has no idea what to do with that specific documents. And when it gets to splitting documents and parsing documents, there are always those tricky formats, like if you have PDF with images and with tables and stuff like that, you really need to pay attention to how not to lose the relevant information. You always can do hybrid, so you don't, even though vector embedding is popular, you always can do keyword search as well and see which one works better and maybe mix them in some way. And you have lots of options. If you already have backend database, some data lake, data warehouse and stuff like that, and it can provide you with relevant information, that's perfectly fine. There is no need to say, oh, vector embeddings and vector databases are popular, so I'll be using them. Whatever works for you, you can try. It's often that you need to ask multiple sources for many documents, and those will be your candidates, but then you want to do re-rank, so you have more specialized algorithm to select, not out of millions of documents, but let's say out of hundreds of candidates, the top 10 which are relevant to you. You can always think about adding some metadata using LLM. So you batch process your documents with LLM and add what you know will be important in your system and what customers are asking for.
Yeah, and here we go back to this new approach to retrieval, where basically you can create sub-agents that will search for relevant context for you. And this is a QR code, which I hope works, but let me know. And there's also a link to this demo done by Cognition. This is a company behind Devin. It's probably one of the best coding agent right now. And what they have in this example is this new retrieval method where they spawn multiple agents to search for relevant context. And in this case, since it's a coding agent, they do it on a code base, and they have this demo running on few popular code bases. So for example, this one is on VS Code, and I typed how does VS Code render the UI, and what the agent does, it runs, for example, grep, and it checks about some keywords in different files, then it reads those files. So it basically does what a human would do, and probably in the long run this will be the best way to get the relevant context for the LLM. But on one hand, it's more expensive because you run multiple agents. It also assumes that your knowledge base has some structures you can take advantage of. In case of code, it's pretty easy because you know, in code it's easy to search for like some classes definition and so on, and it's very well defined. And in other databases or in other data sources, probably some pre-processing will be necessary in order to have a better structure, more understandable for the LLM. And the question will be how to present the structure and how to enable LLM to interact with it.
Yeah, but you always will deal with hallucinations to some extent. So what you need to do, you need to provide accurate info, you need to provide relevant info to an LLM in RAG. If you provide relevant info, you limit the number of hallucinations. But let me show you one very simple yet surprising technique. This technique, what I run here, I run a tool called Nemo Guardrails, and what I ask is, I ask how many goals has been scored in Polish Ekstraklasa in a specific season, and the answers I get is 1800, 800, and 700. So what the tool does for me, it asks the same question 3 times, and we get non-consistent responses, and then the tool run this prompt, and the tool is actually asking if the content is if the hypothesis is in agreement with the context. So context is 2 answers to my question. Hypothesis is the original answer, and the tool says no, it's not in agreement, so it's being flagged as hallucination. So we use LLM to check if the outputs are consistent, and we basically flag it as hallucination. The problem with that approach is that you still have to think about consequences of this approach. That means you do 2 extra queries to an LLM, you do the extra verification prompt, so you add delay, you add cost, and you have to think about like what's the cost of false positive. What if that prompt we introduced is making a mistake as well? So end of the day, we've been talking about many things which could potentially go wrong, and end of the day, we are to some extent back to square one. It's all about data quality, and it's all about carefully engineering the actual solution which is crafted for a specific business case. If you have that approach, if you think that you say shut up and take my money and I'll buy some tool which will do the work for us, that's not the best approach. That probably means you will be burning money, because the tools are evolving very quickly. This is LangChain from 2022 to 2023. Number of code changes. The number of code changes is much bigger, but GitHub couldn't really create such a graph because of the number of changes. But the point is, the tools are evolving, and you need to basically keep up. The tools are quite new, quite not mature, so you need to keep up what's working for you, and don't assume that single tool will solve everything for you. You definitely want to test the retrieval because it's deterministic, but you also need to think about how you find a way of verifying the less deterministic parts, the LLM parts. Very likely you need to come up with heuristics and measuring the actual business outcome, but you need to make sure that your tiny change in a prompt does not break the entire system. And once you have the production system, you need to collect the data from production to make sure how your customers behave. Especially if you have external customers, you would be surprised how people are different and how they are using the system in different way that you would expect. If you have internal customers, that's a bit easier because you basically can talk to them and teach them and assume at least that they won't be using the system in a harmful way. And then every now and then you want to use open source. I used to have this slide, but now I have to remove that part. The open source were really behind the open source LLMs. These days they are much better. You can always think about fine-tuning and training your own LLM, but the reality, always data will be the key, and training your own LLM, fine-tuning requires you to have more, better quality data. Most companies don't have that, so I would suggest to start with retrieval anyway. And why am I talking about the open source? Most of the time you want to use open source LLM on-prem, because when you process your data in your application, that data is being sent to an LLM, and if your provider is Google or OpenAI, you send the data there, and you need to consider the sensitivity of the data and whether it's even acceptable or not. So API will not always be possible. You always have the option of private LLM, but that means you need to have private vector embeddings and private vector database and stuff like that. None of it is rocket science, but the complexity is kind of growing if you have to run those systems on-premise. And then you might say, okay, but on-premise will be cheaper because open source is cheaper. But not necessarily, because with open source, first of all, you need to pay attention to how much extra effort you put into that. And other than that, you will have to buy all those GPUs and all those super expensive hardware upfront before even knowing what your business metric will be, what your conversion rate or whatever you're measuring will be. So calculating the cost of APIs is much easier. This is the price list, the old one. I add the newer version as well, and I put them all together because sometimes you read that, oh, LLMs will be cheaper, but the newer versions of the flag models are not that much cheaper. What you get instead, you get those smaller models, which will be faster, cheaper, a little bit worse, but they might work for your use case. So always good to check if smaller model can solve your problem, because simply it will be cheaper. So when you calculate the cost of API, it's basically calculating of tokens, and you need to keep in mind those tiny little details that tokenizers of OpenAI are different from Anthropic and so on. And then to make it more confusing, Google is charging you for characters, not for tokens. But overall, it should be at least a back of the envelope calculation, which is quite simple compared to the open source, because with open source, you calculate the hardware cost. You don't know if the hardware will bring the return until you actually build the system, and it's quite a big investment up front, and the actual cost per request will differ depending on how many requests you have. It might be that you get millions of requests and the hardware investment pays back. It might be that you will be having not that many requests. You will pay a lot of money for the hardware, but you still have to pay that money because you don't have other option because of regulations, privacy, data sensitivity. So yeah, keep in mind not only the cost for hardware or API call, but how convenient the selection you're making is, how fast you can develop, how much time you will spend on the maintenance. There will always be risk, and you have to basically accept that and assess. If you're doing rocket launching, probably you don't want to use LLMs. But there are other areas where the risk is a little bit lower, and you need to understand what's the business consequence when LLM is making mistake. How can you prevent from that? And for instance, whether you have human in the loop or not. If you have human in the loop, it's much easier because you can always have human which spots the mistake. And I wanted to, before I hand over to Bartek, I wanted to mention, how are you doing with time? Okay. I wanted to mention two use cases which are on completely different ends of the scale. Use case number one is extremely simple. The other one is much more complex. So, generation of training data. Our customer came to us and said, we have machine learning model. It works in German. We are in Switzerland, so we want it to work on in other languages. And the use case was job title categorization. So we want Java engineer, Java software engineer, Java developer to go into the same category. And then JavaScript is slightly different language. Not every recruiter knows that, but yeah, that's the whole point. And it goes to another category. So they had this this model and this training data in German. And then what we wanted to do, we wanted to generate the training data in other languages. We started with translation. Translation didn't work that well, but then we were generating synonyms. And it worked super well, except of some corner cases. So for instance, the job carpenter, what's the synonym of carpenter? Yeah, according to LLM, it's the knight of wood. So every now and then you get those outliers, but it's enough to actually run it multiple times, get the most common options, maybe run it on another LLM, and it was enough to quickly generate training data for other languages. So it's easy. You need to do some cross-validation, and you also need to check the license terms of LLMs, because some of them are quite restrictive of how you can use the output. The other example, much more complex, is about the sales coach. So it's about providing you real-time information about how your sales conversation on Teams, on Zoom goes. So it's about body language, but it's also about what we are talking about, so the vocabulary, but also the tone of voice and stuff like that. So you have, it's much more complex because you have many modalities. Some of the input, some of the processing you can get from multimodal LLMs, like for instance, Gemini is surprisingly good in actually spotting some of the gestures. Like, okay, I lean back, I cross my arms and stuff like that. But it's extremely slow, it's expensive, so end of the day you need to build those smaller, specialized models which are better at cost, better at speed as well. So you end up building custom models. You have human in the loop to some extent. So if so that's actually makes it easier. So if the model is making a mistake, the human still can make a decision. And you have many other use cases. But my point is, you need to assess how complex it will be. So if any of those use cases seem kind of relevant to you, or those ones, I would be super happy to talk to you, but we have 20 more minutes, so we can have a look at some more advanced techniques in the code base as well. Yeah, you can skip
that. Okay, so we have 2 more notebooks, and I think it will be good to maybe go through one of them in details. So the first one is about agents. The second one is about evaluation. And we can also maybe talk about evaluation after the main session. Okay, and this notebook is about structured output and agents. And basically, before we go to agents, we need to understand how to generate structured output using an LLM and how we can use it. And what's the idea here? So the LLM generate text, and the idea is that we can ask it to, for example, generate some JSON in order for our program to automatically parse that and use the parameters it output in this JSON to, for example, call a specific function or do some other stuff for us. And as a result, in this way, we can make the model use some local tools, connect to external data sources, do some actions for us. And What we need to do is provide the LLM in a prompt with a description of those available functions, those available tools. Then it generates the output in a predefined schema we can later parse. And in OpenAI, currently there are three approaches to generate structure and output. The first one, JSON mode, it will be depreciated in the future, so I won't be talking about it. But then we have those two other. The first one is called JSON schema, and it's used to just get a structure output where you don't want to later interact with this LLM. So for example, you load in text from an invoice, you have some predefined schema you want to extract from this invoice, and the model generates a JSON with those fields, and you don't later ask it any follow-up question about this JSON. And the second approach, function calling or tool calling, it is used when you want to take the output from the model, call this tool, and pass the output of the tool or the output of the tool to the model, and you want it to iterate and continue on the task. So basically, it's good to remember that there are two approaches depending on what you want to do. And for agents, we'll be using function calling. For structure output generation, we'll use this JSON schema thing. Okay. And in practice, what you do in Python is you use Pydantic library. You can define some classes, for example, a joke, which will have a setup and a punchline. And what LangChain does under the hood, it allows you to bind a predefined structure to a model. We do this in this line. And then when we invoke this LLM with the structure output, what it does under the hood, it will send the schema for the joke class, and it will parse it from the response from the LLM. And we can, of course, have a look on this in Langsmith. Okay. So it basically looks like this. So the input to the chain is this text, tell me a joke about something. The output is the class, and under the hood, what LangChain does, it passes this output schema to the model. We can see that it was called, so the library detects that this schema was used. It is useful if you have more than one schema, and the model can dynamically decide which one to generate right now. And the framework tries to parse it under the hood. And you can also use some fallbacks. So for example, if the generated schema don't adhere to what you defined, you can send automatically the error message saying that this field is incorrect. You should try to fix this. So in practice, those small schemas will work super well. But if you have a very, very big schema where you have a enum that has 50 fields, then it's very prone to errors, and it can break easily. Okay, and here we show how far we can go with this. And in this example, we define a knowledge graph, which basically has nodes and edges. And we load a part of LangChain documentation and ask the model to help us understand it in a detailed knowledge graph based on the context from this markdown file. So we pass this schema to the model. Here we define a helper class using GraphViz library to plot this knowledge graph. And what the LLM does, it generates diagrams like this automatically. And this was run on, what was the model? GPT-4o. So the previous one. And we can run it again, get a different graph. And I think we had a or it's a good one to try to run it on a GPT-5, because on GPT-5 you get even like bigger results, because the model is just like smarter. It knows that it should divide it into more and more pieces. Yeah, but basically this is what you can get using structured output. Instead of asking the LLM to write some text for you and read it, you can define some structures and you can extract this informations from the text. And here we show another example on explain to me full process of manufacturing plastic bottle with all of the dependencies and submaterials involved in a detailed knowledge graph. And it does this. And once we have this, we can go to agents. And agent is an LLM that has access to some tools, and it can dynamically decide which tool to use in order to achieve some predefined goals you ask it to do. And apart from defining the tools, we will need this agent executor object, which is a predefined class in LangChain that will take the JSON generated by the model. It will try to detect which function was called, what were the arguments, and it will run the function and send the output back to the model. And the model can generate multiple function calls before it will decide to generate a final message that should be presented to the user. And in LangChain there are a few predefined classes you can use for an agent. For example, some Wikipedia query runner to have access to all of the information. There's also a Python interpreter tool, because this one is quite tricky, because usually you don't want to run this code as is on your local machine, because the model can generate arbitrary code. It can try to delete some files and so on. And in practice, it's nice to use, for example, Docker container, or use even some hosted runtime. This tool makes it safe to experiment with it locally. Okay, and here we define those tools. And if you have a look at this tool, it is a Python function, but apart from just a code and the function definition, we have some description and types of parameters and their name, such that the model knows like what to generate in this JSON and when to use which function. And we also have a special prompt, because right now, apart from sending just user and assistant messages, we will also receive tool call message and send back tool invocation result message, which will contain the output of called tools. And in this special prompt, usually it is called a agent scratchpad, and this is the very same placeholder for a list of messages that will be populated with those tool calls and tool result messages. Okay, we define the agent and we run it on a query, search the Wikipedia for statistics regarding extraction of non-renewable energy sources, and write Python program which will create plots of found statistics in Python using matplotlib and so on. So what it does, it queries the Wikipedia, it gets those informations, and it writes the code to plot this. And here, for example, this is a corner case where the system worked, but it didn't work exactly as we expect, because it wrote this Python code, but we passed the tool we passed this Python REPL tool to run this code, and it didn't it didn't run the code. So it only wrote it in a markdown, and this is one of the example when things may not go exactly as planned. And we can also go to Langsmith and see how it looks like. And here is where this tool comes really handy because in agent you can have multiple tool calls, multiple rounds of conversation, and it's very hard to debug it from end user perspective what went wrong. And in Langsmith you can actually see each element of this chain, see the exact input, the exact output, like what caused what, and so on. Okay, and here we also had an example where we connected the agent to SQL database, but LangChain last week released version 1.0 and this example actually broke, so we won't be showing this one. But this example was about how easy it is to use LangChain and connect the LLM to a database, and how good the model out of the box is analyzing what are the tables, running some SQL query in order to answer user questions. So do you have some questions here to the agent part, to the structure output? They have in JavaScript.
Okay, I would suggest we will show QR codes. So, at the end, our LinkedIn, so you can just write to me, and everyone here is welcome. If you guys had such a problem, we didn't expect that, but you can write to me. I can send you.
So this is the link to this one, but it will be maybe hard to display all of the links at once.
Yeah, that's fine.
Yeah, we can.
That's fine. Feel free to reach out to us after, so yeah, we can go deeper into more of your questions. Yeah. Yeah,
Yes.
yeah. So the question was if we can mix those techniques, if we can use agents and tools and RAG. Overall, yes, and in most of the cases you do that, and you carefully tune which parts will work the best for your use case. But overall, you mix that up.
Yeah, because in RAG notebook we showed hard-coded scenario where you always query the database. Here in this, unfortunately, doesn't work. The king example of SQL agent. What we have here were multiple tools to interact with the database. We also defined a tool to check weather, which returned in this example like random sunny or rainy. But basically what you can do is define this RAG as an extra tool, which the LLM can query with, for example, text to search in database argument, and it can dynamically decide whether in this round it wants to query it wants to maybe do more than one call, and so on. So yes, it is possible, and in this case you would just define this RAG as an extra tool that the model can use, but it's not hard-coded in the flow.
Yeah. So before we jump into next question, we still have 5 minutes to answer your questions. But I would really appreciate if everyone here takes the phone and fill out the survey. It was a little bit different scenario than usual, because usually we do exercise, we do it for the entire day, and we have internet. But please fill out the survey. Yeah, and your question? You need to define what will be useful for the system. Then it's to some extent, to big extent, it's the decision of the system. It's based on like what tools you provide, how well they are described, what your prompts are. But then the system kind of in the background is making those decisions. So it's about finding the balance between like very many well-defined tools and smaller amount of tools. So overall, if you provide too many, the system can get confused. But overall, this is something you tune as an engineer, as a developer. You tune the system to provide it with the right tools for the right scenario. And it behaves differently than, for instance, ChatGPT on the website, because on the if you go for the website, it basically do a search, internet search and stuff like that. If you use the API, just raw API, knows nothing. If you want it to search internet, you provide it with a tool. If you want it to query your database, you provide the tool for that. If you want it to write Python, you provide the tool for that.